For centuries, humanity believed the universe was static, that the stars were fixed, and space itself unchanging. But discoveries in the 20th century shattered that illusion. We now know the universe is expanding. Galaxies are moving away from each other, as if space itself is stretching. But in 2008, astronomers discovered something even more mysterious. Something that doesn't fit any model of cosmic expansion. A force, or motion, that seems to pull entire galaxy clusters in one direction. It's called the dark flow, and it might just be evidence that something beyond our observable universe is influencing ours. Let's dive into this cosmic enigma. The discovery of dark flow. The story begins with NASA's Wilkinson Microwave Anisotropy Probe, WMAP, a satellite launched to map the cosmic microwave background, CMB, the leftover radiation from the Big Bang. By analyzing the CMB, scientists hoped to better understand the early universe, but they noticed something odd. Clusters of galaxies. Some of the largest structures in the universe were drifting at high speeds in a specific direction, independent of the Hubble flow, the standard cosmic expansion. This motion wasn't random, it was coherent, as if thousands of galactic systems were being pulled by something outside the visible universe. They were moving toward a patch of sky between the constellations Centaurus and Vela, at over 2 million miles per hour. This became known as the dark flow. What could cause it? There's no consensus yet, but scientists have proposed several wild and exciting possibilities. 1. A massive structure beyond the observable universe. The most straightforward explanation is also the most unsettling. Something exists beyond the edge of the observable universe, something massive enough to tug on galactic clusters. This could be a supercluster of matter, an enormous void, or even a region of space-time with different properties. But if true, it would mean that our observable universe is just a small bubble within a much larger and stranger structure. And that brings us to 2. The multiverse hypothesis. What if the dark flow isn't caused by something in our universe, but by another universe entirely? According to the multiverse theory, our universe is just one of many, each with its own laws of physics. Some inflationary models suggest that during the birth of the cosmos, different regions of space inflated into their own universes, bubbles floating in a higher dimensional space. If one of these universes passed close to ours, it could gravitationally influence our matter, pulling galaxies toward it. That's right, the dark flow could be the footprint of a neighboring universe. 3. A flaw in our cosmological models. Of course, there's a more conservative idea. We might be misinterpreting the data. The motions we observe could result from local inhomogeneities, massive nearby structures we don't yet fully understand, like the Great Attractor or the Shapley supercluster. Or it might be an artifact of how we measure galaxy velocities. If that's true, then the dark flow isn't real, just a mirage created by gaps in our understanding. But the evidence remains intriguing and hasn't been entirely explained away. Why it's a big deal. If the dark flow is real, it changes everything. It means the cosmological principle, the assumption that the universe is isotropic and homogeneous on large scales, might be wrong. It suggests the universe isn't smooth and uniform. It's structured, influenced by forces and realms beyond what we can see. It could even provide the first empirical evidence for the multiverse, something that was, until now, purely theoretical. And it forces us to rethink our position in the cosmos. We're not just floating in space. We may be drifting through a vast sea of unseen forces, unknowable neighbors, and ancient gravitational tides. Where we stand today. Since the initial discovery, additional surveys have tried to confirm or disprove the dark flow. Some support the finding. Others suggest it's a statistical fluke. More advanced missions, like Planck, didn't find strong confirmation, though they didn't rule it out entirely. The debate is ongoing, but future projects, such as the Euclid Space Telescope, Vera C. Rubin Observatory, and Nancy Grace Roman Telescope, will map the cosmos with the unprecedented precision. They could finally resolve the mystery, or reveal something even stranger. Could we ever detect what's beyond? By definition, the observable universe is limited. Light from beyond 46 billion light-years hasn't had time to reach us since the Big Bang. But gravitational effects don't follow the same rules. If something massive exists just beyond our cosmic horizon, its gravitational tug can still affect matter here. That's what makes the dark flow so compelling. It might be our only window into what lies beyond. And if there's structure, or even life, in a universe adjacent to ours, dark flow may be its distant whisper. Final thought. The universe has a way of revealing its secrets slowly, in shadows, in subtle nudges, in patterns that seem almost too strange to be real. The dark flow is one of those secrets. It may turn out to be an illusion, a measurement error, or a glimpse into the most profound truth we've ever faced, that our universe is not alone. Here on Infinity Beyond, we follow the signs, no matter how faint, in search of that truth. Because sometimes it's the invisible forces that tell the greatest stories.